Hello, welcome back. In today's episode, we're going to go deeper into Gradle. We will tackle Gradle Tasks, Plugins, Properties, Settings, and the Gradle wrapper. Let us have a quick recap as to how a Gradle file looks like. At the top, we have our plugin section, Kotlin JVM plugin. Next, we have the group and the version ID of our Gradle project. We also have repositories section that has set up Maven Central as our primary repository for dependencies. We have our dependencies section, which specifies a test implementation. We also have a task section. Next, we have the Kotlin section. It specifies which JVM version to use. This section has been provided by the Kotlin plugin that was initiated at the top. Let us look at Gradle Tasks. You can think of a task as a set of instructions for Gradle to perform. This includes, but are not limited to, compilation of source code, running of tests, building of artifacts, publishing to a repository like Maven or something else. These tasks can be defined from plugins that have been installed or even your own. We can view available Gradle tasks by running the tasks function. The process of building a project usually involves a number of steps, and these steps are what we have referred to as tasks. Similar to dependencies, tasks can also depend on other tasks. We will discuss this a bit later. We can create new Gradle tasks using the task builder. Let us have an example of a Gradle task that prints hello world onto the screen. To define a Gradle task, we usually use the tasks option.create. You can give your task a name and then provide a block where you'll define the task. You can have this task have a description. You can even categorize it into a group. Let's have it as hello. Let us print line. And that is your Gradle task defined. IntelliJ IDEA allows us to reload the Gradle scripts by simply pressing this refresh button. Let us try and run this Gradle task. To run your Gradle task, you'll simply need to invoke the Gradle wrapper and the name of your task. The build will start, and then lastly, you will see your message, hello from Gradle. With the current versions of Gradle, instead of using the create function, you should use the register function. The register function does exactly the same thing, however, it does it in a lazy manner. Meaning, if we didn't need to have the greeting task, the build system will not spend time using resources in order to configure it. Let us replace the create with register. We can rerun this again. The results will be the same. In principle, since Gradle uses general-purpose programming languages for build configuration, you can do whatever you want in your builds, including even writing complete programs that are not build-related. In fact, we could even say Kotlin and Groovy in hand are actually way too powerful to just be build configuration languages. Let's try and create a Fibonacci sequence and see how this works. Let us register a new task known as Fibonacci. Let us assume that this sequence will show us the first 10 numbers. Let us add a description, give it a group, and then lastly, we can even define how the order of execution would work. So you could have a do first block to ensure that that specific action is performed first. You could also have the do last block that ensures it performs the action last. Start by printing out 0. 0 is always the first term of the Fibonacci sequence. Next, provide two variables, after which provide a for loop. The next thing you'll do, you will indicate that second will add on to first, and then first will become whatever was initially in second. With that, we can execute this task as well. we can see the first 10 Fibonacci numbers. We can even receive parameters onto Gradle Tasks. Instead of having an absolute number here, we could provide a property. To get a property, we'll simply store it in a variable. Let me call this count, and it will be equals to the properties option. Then you would look for the count property. Since this is nullable, we need to be null safe and then convert to a string, after which we'll lastly convert it to an integer. Since this might be nullable, we'll use the Elvis operator to provide an alternate value. So we can replace 10 with the variable known as count. Now, to provide this parameter, it will be in the execution of the build. To do this, we'll follow the same procedure. Gradle, provide the name of the task, and then to provide the parameter, you will have the flag P in uppercase, then provide the name of the variable that you wanted to pass in. So our variable is known as count, and then equals, you provide the value. So let's say 15. Once you execute, you can see the first 15 values. Gradle tasks can also be abstracted into classes. This can be done when you want to write a much more sophisticated build script and you don't want a lot of bloated set of tasks like this one. In the event we wanted this to be something very, very long, then this would start to look very, very untidy. So you can do that by providing an abstract class. Let us call this the fib class. We'll use it to do the same Fibonacci sequence, and you'll have to inherit the default task from Gradle. Within this class, we can provide inputs if we want. So we'll need an input rule. So maybe we have count, and that is a property that we will have, and it will be of type int. We can have a function that contains the steps that will be executed once the task is run. So maybe I can call this run. It can actually be any name that you wish. So I'll just call mine run. We can start by checking whether count is a negative number or not, since we know Fibonacci sequences only run on positive numbers. So I can say if count, we'll need to call the get function to provide the value. So if n.get is less than 0, that is if it is a negative number, the first thing we'll do is we'll just throw an exception. Now, there are several types of Gradle exceptions that you can use. We won't cover them in this course, but we'll just use a standard one that stops execution. So we have the stop execution exception. Alternatively, if the error is non-existent, we can reuse our earlier logic. So I'll go on ahead to copy that. Now, if you want this function known as run to be the default one that is executed when this Fibonacci task is run, you can annotate it with task action. So task action will immediately be called the moment the task has finished setting up. Now we can try and set up this task. You can have this contain a type. So our type is fib. We'll call this one fib. So this will set up every single thing in our fib function. Our only item left is to set up the count. So we'll just say count dot set, and we need to provide the value. So with this value, we are again going to call the properties function calling count, and then dot to string, dot to int, and if we don't get that, provide the value default as 10. So this will now be the same exact thing as what we had earlier. You can provide a description if you want. You can put it inside the init block. In order to view all your tasks that are available within Gradle, so that you may have a hint as to what is happening, you could always use the tasks function. So we could say Gradle w tasks, and we'll have a list of the tasks. So you can see tutorial tasks. This is where we set out our group as tutorial. So you have Fib and Fibonacci. We have some for verification. There's the check task, test task. Tasks can be made to be dependent on each other. Inside our task registration, we can simply provide the depends on, and then set out tasks dot find by path. So this will allow us to find it by the name of the actual task. And this will make sure that the greeting function is executed first, and then whatever else you want to do is done later. And you can see the first thing that happens is hello from Gradle, and then the Fibonacci task is run. You can also define a task, or you can find a task by the type. Instead of finding by path, where you specify the name, assuming we had several Fibonacci tasks, or Fib tasks in our case, that has this type Fib, but you want each to have different set of values. So let's say, assuming you want Fib, Fib2, and Fib4 to run before greeting is run, we can simply add depends on, and then you can always find the tasks. So there's the with type param, and you can just provide the type, which is Fib. So all Fib tasks will run before hello from Gradle. We're still providing the count parameter because one of our tasks requires the count parameter. So in as much as we're using the greeting task, there is still a task that requires the count parameter. So we run that, and we can see that there's Fib, which takes us to the first 5. There's Fib2, the first 2, and then there's Fib4. We can notice that hello from Gradle is executed first. And this is because we did not specify at what point that hello from Gradle should run. So we can put it inside a do last block. Gradle supports plugins. A plugin is a set of tasks that help deal with something specific, either Kotlin, Java, protocol buffers, among others. The plugins block is usually compiled separately and before anything else. After that, artifacts from the plugins that have been compiled are placed in the class path, which now allows the IDE to provide auto-completion and other useful features. Gradle plugins are a good way to abstract more than one single task. Maybe you might have a number of tasks that have shared configuration, initialization steps, among others. In fact, most of the standard Gradle features for building Kotlin or Java projects are implemented as plugins and are not even built into Gradle itself. An example are the blocks that we saw. The Kotlin block in this case, provided by the Kotlin plugin. And the Kotlin plugin has been defined at the very top. So we have Kotlin for the JVM, and this is version 1.9. Assuming we had sub-modules within our project here, and we wanted this Kotlin plugin to be defined in the root project, but to only be used in the sub-projects. We usually use the apply false option. So what this will do, it will necessarily not use the Kotlin plugin setup within the root project, but it will apply it in sub-projects. This will make the plugins version to be inherited by the sub-projects and automatically used there when you execute a sub-project's plugins block. Gradle offers a simplistic way of setting up your own project level plugin. This is done by providing it inside a class. Let us create a simple plugin. Still in our build.gradle file, we can create a plugin by providing the name of the plugin inside a class. So let's say we have our Apples plugin, have it inherit the plugin class, and the type is the project level plugin. And then you must override the apply function. The apply function will come in with the target project, and then you can register as many tasks as you want. So let us register one task here, and to register a task, we register them from a target. So you will say target.tasks.register, and then provide a name of your plugin, provide your block. Within this block, set out something. So maybe we want to do last. You can provide a description. So to use a custom plugin, we usually just use the apply function and then provide the type of plugin that you have. So apply Apples plugin. So you can check whether first the task is there. This was called custom plugin. Yes. So you can see custom plugins task. There is a task known as Apples, and we can just run that task. And you can see that an apple a day keeps the doctor away. It is important to remember that plugins defined within your Gradle build script cannot be used into any of your sub-projects. An example would be if you have a multi-module Android project or a multi-module Compose multi-platform project, any plugin that you define inside the root project would not be available into your sub-modules. Or even if your plugin is just too complex to be included in the build.gradle Kotlin script, you may place it in the build source directory of your Gradle project. This directory is very similar to any other Gradle project. Let's start by creating our build source directory. We could have our Gradle file. So this is our build.gradle.kts, since we'll be using a Kotlin script. Next thing we'll do is we'll add a new package. And within this one, we could have a new file. Fantastic. So we can start with a build.gradle file in order to set up a few things. So we'll start with the plugins block. And then maybe the other thing that we can write is the repositories. And they're coming from Maven Central. Last but not least, we can include the Java Gradle plugin. And then we can try to refresh the builds. Fantastic. We've set up our build.gradle. The next thing is we'll go into our oranges plugin file and define our task as well as our plugin. So let's start by defining the class. So we're going to have an abstract class known as oranges task. You could describe your property. So you can just say description equals to standard oranges radius. We could also have our task, so we can have annotate with task action. So this is what we run by default. And then you can provide your plugin after this. So to provide your plugin, we can have our oranges plugin class, which inherits a plugin for a project. We override the apply function. Let us set up our task. So target.tasks .register, and then providing the name of the task. So we're just going to call this oranges task, and then we'll have to specify the type from our custom task. So it's just going to be oranges task, and then invoke the Java class, provide the block. So this block will indicate all the items that you want to do within this task. So you can set out our radius. So it.radius.vet. Maybe they are all 5 centimeters in radius. It's too big of a range, so let's say 3 centimeters of radius. Head over to our build.gradle inside our build source, and we can now define this plugin from here. So we can indicate Gradle plugin, and then provide the plugins block. After that, we can now have our create function. So this will create our plugin for us. Provide the name. So I'll just match the two names. Oranges plugin. Then give it an ID. And then you can also specify the implementation class. And this is oranges plugin class. After setting up your plugin, provide the plugin details in the plugins page in your root project. In this case, we have ID oranges, so you need to provide the ID that you had set up before. In our case, it was oranges, and you can find it back here. Let us run that oranges task. So we can say Gradle W oranges. And you can see, hello there, this orange of radius 3 centimeters is not able. Great. You now know all the concepts around building Gradle plugins. You can check out the Gradle Enterprise documentation pages in order to learn more about building your own Gradle plugins. Properties are used to configure the behavior of Gradle itself and specific projects. Let us try and use the Gradle.properties file to do one or two things. This file is usually found in the root of your Gradle project. So we have Gradle.properties. We could provide a value. So it is good to note that the Gradle.properties file stores values in key value format. Assuming I want to have the Fibonacci count, so I can call this fib count, and I can have this equals to 20. Then head back to our build.gradle file. And then instead of us having our count here, we could try to find it first. So before the task registration, we could just have and then you can use delegates to find it. So by project, we need to specify the type. So this is an integer. And then within this fib count, you can now just, instead of having a count here, let us just have fib count here. You can run this, Gradle W, Fibonacci. We do get an error, and this is because all properties are defined as strings. So we need to convert the string into an integer instead of directly casting. So you can have this as a string, refresh that, and then lastly, can set out Fibonacci, and you can see this is our sequence. If your Gradle property is a mixture of several characters, you cannot use delegation. An example would be, in our Gradle properties, we have this kotlin.code.style as our property. Let us try and find this inside our Gradle script. Then we can use this value inside our Fibonacci task. We have Kotlin goes down. You can now run the task again, and you can see the code style used is official. So you have two ways in which you can do that, by delegation or by using the property object. Before Gradle assembles the projects for a build, it creates a settings instance, after which it loads the settings file onto it. You can only have one settings file stored in the Gradle project, and it is used to do a few things. Adding sub-projects to the build. You can modify the parameters from the command line, maybe adding a new project property. So in case you got certain set of params and you wanted to change them, you can change them from within the settings file. And you can also access the global Gradle object to register things like lifecycle handlers. Let us have a look at our settings file. So it is known as settings.gradle.kts. Within our file, we can set up configurations for things like plugin management, dependency resolution approaches, the set of repositories that we expect to load. We can even set out global plugins that we want to use within our project. You could even include a repository from GitHub. There's a source control block. Within this block, you can provide the Git repository section, and then you can maybe say URI.create and then provide the Git repo here. And then after that, you would want to indicate a specific module that you want to load. So you could say producers module, and then you can provide the name of the module. So assuming you have a Git repo, and then it's another Android app that has several set of things, you could provide the repository there and then load a specific module. So assuming you want to only just use a certain portion of the repo and not all the others, you can specify the specific module. You could also include other sub-projects within your root project. You'll notice that the build source sub-project will not be included here, though it is a sub-project inside our Gradle project. But that is because build source is a special type of sub-project, and Gradle will always find build source as part of configuration, as opposed to being an actual sub-module or a sub-project. Once your module is set up and configured, we can always just indicate that you want to include it. So you say include, and then the sub-project will just be the greetings one. And that's about it. If you wanted to include a module, so you can include as many as you want, just separated by a comma, maybe another module, and so on and so forth. So since these modules are currently not compiled properly, we won't bother to compile this, but that's how you would include them in your specific settings file. Lastly, we have the Gradle wrapper. The Gradle wrapper is a shell script that downloads and caches the required version of Gradle. It's usually stored in two main types of files. The first one is the Gradle W without any extension. This file is used within the Linux and Unix environments, Linux itself and Mac. So those two operating systems will use the Gradle wrapper in that format. But if you're on Windows, we use batch files, and it is indicated using the Gradle w.batch file. The version of Gradle that you're using is usually specified inside the Gradle wrapper.properties file that is stored inside the wrapper subdirectory inside the Gradle directory. So if we go into the Gradle directory, we'll find the wrapper subdirectory, and there's the wrapper.properties. And if you open, you will see a set of things to deal with your Gradle distribution. So you'd have where the distribution has been stored, the URL. The URL will specify the version. At the time of recording the video, we have Gradle 8.2 as our version. Gradle can do way more than what we've just done. It supports additional features which we may not cover in this course. However, you can take the time to go through the Gradle documentation. They have very, very, very good guides in their documentation pages. You can check out things like caching using Gradle, setting up multi-module projects. We've spoken about how you can include sub-modules into your Gradle project. They have extra blocks that you can use. We have all projects, sub-projects block. We have publishing block, artifacts block that allows you to specify different other things. Things to deal with compatibility. So a certain Gradle version and a certain Gradle plugin might not be compatible, and how you can resolve things around that. Resolution strategies, of course, and things like source sets. So when we get to the Kotlin multi-platform section of this course, you will be able to identify how can we use different source sets to provide different things. In our next episode, we will look at Kotlin generics, reflection, and type erasure. See you then.